Hi, I'm Natalie.
Hi, I'm Andrew, and this is our investigating inelastic 2D collisions lab.
The goal or main research question we were trying to investigate through our experiment was to see how changing the angle of two colliding balls affects the fraction of kinetic energy lost. For our experiment, we changed the angle at which ball 1 was colliding with ball 2 in two different trials. Measuring velocities and angles using tracker, we were able to find the percentage of kinetic energy lost as well as the coefficient of restitution. From our data, our main finding was that the larger the angle a ball is rolled results in a larger loss of kinetic energy after the collision. This was compared to a ball rolled at a very small angle, and the kinetic energy that was lost was much less than that of the larger angle. On the upper right, we have our system schema where we have ball 1, ball 2, and the Earth. The two balls have contact with each other, and the Earth has contact and gravity on each of the balls. Both of the balls were placed into the system. On the bottom are our energy pie charts. The first chart is represented with kinetic energy as ball 1 starts rolling. The second is during the collision, where kinetic energy is still present as they're both still moving, but there's also internal energy as friction between the two occurs. The third chart is just kinetic energy as the balls separate, but the chart is smaller to show that some kinetic energy from ball 1 was transferred to ball 2 due to energy conservation. To set up our experiment, we placed a meter stick on the ground to represent the x-axis and placed ball 2 at rest on one end. Then we rolled ball 2 towards ball 1 to create a collision. We conducted two trials where the angle in the first trial was significantly smaller than the angle at which ball 1 was rolled from the second trial. Using the tracker software, we were able to record values for velocity for the two trials and measure the exact angles. From this, we were able to calculate the fraction of kinetic energy lost in the e-value. We defined our independent variable in our experiment to be the angle ball 1 was rolled towards ball 2 and the dependent variable to be the velocities of ball 1 and ball 2. The graph to the upper right shows the velocity of ball 1 before and after the collision relating to the x component. The graph to the lower right shows the velocity of ball 2 before and after the collision relating to the x component. This collision occurred at a 4.9 degree angle. The graph to the upper right shows the velocity of ball 1 before and after the collision relating to the x component. The graph to the lower right shows the velocity of ball 2 before and after the collision relating to the x component. This collision occurred at a 49.7 degree angle.
The graph to the upper right shows the velocity of ball 1 before and after the collision relating to the y component. The graph to the lower right shows the velocity of ball 2 before and after the collision relating to the y component as well. The collision occurred at a 4.9 degree angle. The graph to the upper right shows the velocity of ball 1 before and after the collision relating to the y component. The graph to the lower right shows the velocity of ball 2 before and after the collision relating to the y component as well. The collision occurred at a 49.7 degree angle. Through our calculations, we determined the coefficient of restitution between the two trials. In the first trial, we found out that E equaled 1.97 meters per second. In trial 2, it equaled 1.72 meters per second. We also calculated the kinetic energy lost before and after the collision for both trials. And for trial 1, there was a negative 289%, 5% kinetic energy loss from ball 1. And in trial 2, there was negative 196% kinetic energy lost. We know that due to the conservation of energy that some of the kinetic energy from ball 1 would be transferred to ball 2 during the collision. As both balls are within the system, however, after calculations we found out that all of the initial kinetic energy was transferred between the balls. This was a result of rotational energy being charged into translational energy. Another physics concept present in our experiment is Newton's first law, as it applies specifically to ball 2. Ball 2 is at rest until an extreme force, which is in our scenario is ball 1, collides with it to cause a change in motion. Based on our data, we were able to conclude that the larger the angle at which ball 1 starts rolling from ball 2, the more kinetic energy is lost. Throughout the duration of our experiment, several factors may be taken into account to explain limitations of our data and trials. First, during trial 1, ball 1 ran into the meter stick upon colliding with ball 2, which may have resulted in the velocity of ball 1 to slow down sooner. Next, other forces such as air resistance and friction between the balls and the carpet may have altered the velocities recorded. Human error also occurred as the velocity and force of the ball was not consistent. After analyzing our calculations, we realized one reason for the unusual results in large e-values may be due to the fact that the energy changed from rotational energy to translational energy during the experiment. Lastly, experimental error from the tracker software may have resulted in skewed graphs for the velocity versus time and could have also resulted in the increase of Ke instead of the loss of Ke.